All right, AGS1, welcome back. We are going to knock out 2.5 today, making my point. Some things we're going to need for our toolbox today. We're going to be talking about slope-intercept form of line equations, which is y equals mx plus b. That should seem familiar. We've definitely talked about it. The one kind of new thing we're going to talk about today is something called point-slope form. Point-slope form is just an alternative way to look at an equation of a line. So y equals mx plus b is one of the ways, and then y equals m times x minus x sub 1 plus y1. The essential question for the day, how else can we write equations of lines, and why would it be useful? Let's find out. First up, we're going to look at a block pattern. So please notice that this is figure 1 right here. It's kind of this little figure, and it's got, well, let's talk more about how it's going to grow, because the jump from 1 to 2 is really what I'm interested in. To get from here to here, I see that it grew. Now, how many blocks did it add? I see the original figure. Maybe I'll do it in blue. The original figure is like this block, this block, this block, this block, this block. But the blocks that got added onto it are this top one, this one, and then 2 on either end. Oops, did I? Oh, I forgot to put a blue one there. This is part of the original figure. So, if you count up those red dots, 1, 2, 3, 4, 5, 6, that means there was a plus 6. 6 blocks got added. If I look at the third figure, oh my gosh, it's grown again, you guys. The third figure is, if I kind of look in the middle of it to find the second figure had 1, 2, 3, 4, 5 on the vertical. So 1, 2, 3, 4, 5, and then 4, 8, 9 on the middle, so 4 on either side. So I'm just highlighting the figure 2 block so we can see how it grew to get the figure 3 block. So any ones that I didn't fill in are new blocks from here to here. So here's 1, 2, 1 on top and bottom, and then again there's 2 more on the left and right. So this was another plus 6 jump. Some thoughts about this. It's arithmetic. It's growing arithmetically. But we've been kind of saying in terms of functions that this is a linear function then. That means it would make a straight line on a graph. So, if I want to write the explicit equation for this, it would be f of n is equal to what is it? The slope? Well, are we saying slope? It's the common difference times n plus the 0 figure. But you guys, for the 0 figure, you actually need to go back a whole step. So if we go back to the 0 figure, I didn't really leave room for it, but I would have to take off this, 2 on the left and right, and then 1 on the top and 1 on the bottom. So I think that the 0 figure, if I were to add it in, 0 would look like this, just 1 block. And then it would jump plus 6 up to this one, getting these 6 blocks. 1, 2, 3, 4, 5, 6. So the common difference is 6 times n, and then there's 1 block in the 0 figure. Excuse me. Now, you guys, if I take all that info and count up how many actual blocks are in each figure, like this figure, let's get a different highlighter. This figure has 1, 2, 4, 6, 7 blocks in it. This one, it got added 6, so that's 13, and then added 6 again. So the pattern is that the first figure has 7, then it jumps up to 13, then 19, and then we didn't draw the fourth figure, but it would have 25. If you kind of break this apart into the patterns, it's like it starts with 7, and then it gets a plus 6 on the second term, 2 plus 6s on the third term, and 3 plus 6s on the fourth term. Do you guys see how the amount of plus 6s are always 1 behind this figure? that means we could write the equation for this as the original 7, that's figure 1, plus 6, the common difference, how much is being added each time. Sorry, cleaning up my handwriting. Plus the common difference. But then this part is always 1 behind the n value. So if I was to take this down to n, that would mean this would be n minus 1 right here. So this is like an alternative form of the equation. Please notice that this part and this part, 1, 7, are like a coordinate from up here. That's going to come into play later. Now, this part that I was just talking about right here, this is kind of point-slope form. So let's talk about slope-intercept form, and then we'll talk about point-slope form. Slope-intercept form, this m part right here and the common difference, they're the same thing. This is your slope. These guys on the end, the b value and the 0 point. Another way to think of the 0 point or the start value is the y-intercept. Which we've been calling the 0 point. Yeah, it's when x is equal to 0. Now, the point slope form is useful sometimes because you just need any point that's on the line and the slope. You actually don't need the 0 point or the y-intercept. Like up here, I found this equation by not actually using the 0 point at all. We just used kind of use this 0.17 here. So some commonalities is that it still has m in it. This is still your slope slash common difference. This right here is your input. I guess I should have labeled that on the other one as well. That like here, this is your input. And then this is your output. So same thing over here, that x is the input and this y is the output. Now, this x1, y1 can be any point. So this is a x1, y1, any point on the line. The advantage of the point slope form is that you don't need the y-intercept or the 0 point. Yeah. So, in terms of building up the equation, there's two different ways you can look at it. You can make a slope-intercept form, a y equals mx plus b, or you can make a point slope form, which is y equals m times x minus x1 plus y1. All right, guys. Remember to do your ALEX tomorrow for 45 minutes, and then we will hit 2.6 on Thursday.